Hi there, did I scare you? In this experiment, we are going to look at light-dependent resistance. So you can see I'm in a dark room, like I turn off the room lights, okay? And we're going to look at a device that is very useful in our day-to-day life, which is something that you have learned in your theory. Okay, excuse the fireworks, something that you have learned in your theory, but maybe you have not actually studied it or felt it before. Okay, so this is the light dependent resistor. I have it in my hand. I'll show you later once I turn on my room light. But the uses of the light dependent resistors are so many. If we connect it to a potential divider circuit, it can help us adjust the automatically adjust the ambience light. It can help us decide when to turn on and off your coffee machine. You can program your coffee machine to turn on when the sun rises, etc., etc. Okay, including adjusting a light like this, ambient light at home, by quickly pressing on or changing the exposure of this light. All right, so I'll see you in the setup shortly. Okay, hello, I am back. This is experiment set 8, SAM2 set 8 for your paper 3 preparation. This will be the last experiment. Maybe we will add on some, those we haven't decided yet, but this will be the last one in your semester 2 lab manual. So in this experiment, you will investigate how the light intensity incident on the light sensor varies with distance from a light source. Okay, so you are provided with a lamp mounted on one end of a black paper tube. So if you are doing this in the college that you are studying with me in, okay, at every college will have a slightly different setup. So for our college, or for the setup that I have in front of me, instead of having a black paper tube, because imagine every time we do this experiment we have to use some black paper, so that would be quite wasteful lah. So we decided to use a PVC pipe. Okay, so this is my PVC pipe, okay, where these two ends are can be connected to a power supply. Okay, so if I want to follow the diagram, this is the PVC pipe and the power supply will be there. All right, together with a light sensor in the form of a LDR mounted on a half-meter rule as shown in figure 1.1. Okay, so whenever you are given something that looks very new, right? So, wow, never see before. Wow, we do so many experiments. That what is all this? Okay, so first thing you need to do is you need to try to make sure that everything on the diagram is there. It's a little bit like doing IKEA lah. You buy some furniture on IKEA and you're like, how do I put this together? Okay, one by one, we do stock check first. Okay, so first thing I want to do is I want to be able to know how on earth am I going to get this 6-volt DC power supply. Okay, so normally or previously, all your circuit experiment, we give you like a single cell battery, a 1.5-volt battery. But now this is a 6-volt DC power supply. So there are two ways that we can give this to you. We can give you 5 times the double D battery. 5 times? Wow, my maths, sorry. 4 times your 1.5-volt battery. Or we could give you something that looks like this. Okay, so this is your power supply. I believe this will already be plugged in to the 3-pin plug, but in case it is not, especially when you have something new, I take some time, stare at it, play with it a bit. Oh, like that one. Oh, got label one. Okay, so I'm guessing that the connecting LED that connects to this PVC pipe, see this one here? This one, good God, is connected, these two connecting LEDs here, okay, is going to be connected to this power supply. So I'm okay with that. All right, and the second part is this one. So when it comes to this one, I actually need to go and stare at it a bit, or rather I want to bring it very close. Hopefully you can see. Give it some time to focus. Are you focusing, my beautiful camera? Okay, so you can see this is called the output voltage select. Okay, output voltage select. It's not very clear because The camera is struggling. Can you focus, my dear camera? Are you okay? Alright, give me a sec to help the camera focus first. Okay, I think this is good. I just need to make sure I don't breathe too much. So output voltage select, there are certain power ratings ranging from 3 volt to 6 volts. 3 volt will be on the most right. 6 volt will be where it is. And I think the largest one is 10 volts. I'm staring at my screen right now. 10, 12. So in person, this will register clearer lah. But right now it's just very blur. So this is an example of a variable voltage power supply. You can adjust this knob. So like right now it is 3 volt. Okay, the far left is 3 volt. And you can push it to the far end here. This is 12. Okay, so hopefully that is good enough for you at home. All right, so every voltage or variable voltage is different. So don't get used to like, oh, it must look like this, it must look like this. Okay, when you're not sure, always raise your hand to ask. But in this case, I don't think there's much to ask lah. You can tell that this is, it says here, output voltage select. So you select your voltage, 6 volt. Okay. Do not simply change it if they already set for you. Basically, if you're not sure, just go and ask lah. Ask someone. Go ask. All right. Or they should already tell you. Okay. So novel instrument, don't panic. This is what it is. And now I'm going to, does it focus better here? Can you see the voltage select? Okay lah, it's enough. Can see, cannot see, then too bad lah. I did my best. Anyway, this one, I'm going to plug it into my power supply, all right? On the floor, because I'm still recording this at home, okay? And I will connect this to the lamp. So the second thing I'll do is I will take out this and stare at the light. All right, so there's a light here. And I need to make sure that this lamp doesn't burn. And how do I make sure that the lamp doesn't burn? you make sure if they say 6 volt, you use 6 volt lor. You don't go extra, go and put 12 volt, and after that, the lamp burn liao. Then how? Cry lor. Okay, hang on, let me double check. I have indeed placed it at 6. Yep, it is 6. Okay. Stay. You're good. Alright, so now I'm going to connect this directly. And because this is a lamp, so it doesn't seem to matter which one is positive, which one is negative. Means connect directly. The drawing says connect directly, so I'm going to do so. Okay, so positive to positive. Yeah, you can see here. Alright, negative to negative. Oh, so you can see it will light up. Okay, it looks okay to me, right? It's not too bright, not too dim. Doesn't feel like it's burning out. But a few precautions here lah. This thing will become hot, obviously. Alright, and the second thing is when you're not taking reading, please unplug the power supply. Okay, if not, then it will burn, Then we have to buy new light bulb for you, Okay, so another thing when you plug and unplug this thing, right, is that you should prevent damage to the wire here. Pull out on this end. So you pull here. Okay. And you pull here. Because they can be quite tight. So make sure you do that, right? So when you put it in. Okay, I'm satisfied with this. And I will put it back to where it belongs. Okay, but I also know that I need to measure from the top of the lamp. And what we did, or what they did was, they see that the base of the lamp maximum can only enter this thickness, this much. So by estimating that both of this, kind of estimating a bit, we think that the lamp is here. So we place a sticker and then we make a mark here. Okay, so if this sticker or this marker is not available to you, you might actually need to do your own marking, because we are going to measure L from the top of the lamp. There, here. Hang on. this part here. We're going to measure from the top of the lamp. So this is the top of the lamp once I put it in, because if you look at the side here, this is where the edge will meet. Okay, hope that makes sense. So now I'm going to put it in. All right, and I will make sure it is closed. And inside here will be pretty dim, but you can always double check. So you can see inside we can have the lamp lah. All right, so instead of using a black paper tube, we use a PVC tube, which is good enough. It creates a dark environment, so I don't have to turn off my room light and scare people. Okay, all right, so this one is done. The next side, so I'm going to put this one side. This is okay. All right, the next one is this. You will have LDR. This is the LDR mounted here. Does it look like it? This one? Does this look like this one? Hang on, let me look like this one, right? This one. Look like this LDR here. Nah, this one. So when you think about this LDR, we also have to measure the distance X lah, I'm guessing. But before I care about that, I'm going to look at the half-meter rule. Wow, so helpful. Instead of using this in the half-meter rule, which will make it very hard to put in this tube. Okay, very hard to put in this tube if it's a half-meter rule. We actually paste the scales for you lah. All right, so we're going to go from 1 cm all the way to, unfortunately, we don't have half, so I think we go all the way to about 28.5. That is the largest one. Okay. All right, and then at the end here, you have these two things that look like shoelaces, kinda. This is the This is to connect to the resistance meter. So far in all your experiment, you have used this one time as an ammeter for your very first circuit experiment, where the reading jump here, jump there, all over the place one. That one has to be expected. And all the other times, you have used it as a voltmeter, either because you want to find the balance length or you want to find some potential difference lah, right? So in this experiment, can you see? Okay, we are going to use this as a resistance meter or an ohm meter. Okay, so let's see if it focuses now. So all the resistance meter, all the ohm is here. You can see the ohm is here. The ohm is here. So I'm gonna just go and turn. Okay, so there will be a certain rating that you are told to use. Okay, so I have set the ohm meter at 20k. Focus. All right, set 20k lah. Can see more. Let me turn on the light. Is it clear? At 20k. Okay, 20 kilo ohm. So whatever number you get will be 20 kilo ohm, right? And the whole idea of this is that we are now going to connect this LED. This LED is connected to the white color. I'm not sure whether it's going to be white lah. Okay, so it's connected to this. You just gotta trust that it's connected inside lah. Please don't open this one up to see. Please, just don't. Just connect first lah. Try it out. So I'm gonna connect this. It doesn't matter the positive or negative, because LDR is LDR. Light dependent resistance, not long distance relationship although now lockdown everyone long distance relationship. Okay, so here's how you test it out. You can see when I connect directly, I already have reading around 13.7, 13.8 like that. Okay, so this is because this is exposed to the lighting. Okay, so now if let's say I point it upwards and it's exposed to the lighting of this camera, you can see the resistance has dropped. So this is 2.36 kilo, sorry, 2.36. It's been a long day, children. 2.36 kilo ohm. Because, remember this? You can see more. This is connected to, this one need to be overexposed. Connected to 20k. So whatever number you get here is in K lah. So this will be 10.9k. So of course you can see if I bring this one up and shine the light directly, the LDR resistance will drop. If I bring away the light, ooh, the LDR resistance will increase. So does this match your theory? You can actually take some time to pause and think about it, because LDR consists of semiconductors, right? So semiconductors, the electron, they're very chill one. They're just lazy to move. You know, like you at the 8 a.m. class, just very chill lah, just no energy, you know. So if I cover this, ooh, become infinity. Okay, so I cover a bit, cover a bit. Alright, so if I cover it in my hand, you can actually see that it actually will max out the reading lah. Alright, I can bring it to 16, 15, okay. So in order for the electrons to receive more energy and be more mobile to carry the current or the charge, because resistance is resistance for the charge to move or the electrons to move. So if you want the electrons to be more energetic, what we will do is we need to give it energy. All right, and one of the ways to give it energy for this semiconductor is to shine some light. Okay, so if I raise it up, or even better, I put my little light here. Ooh, look at this, look at this, look at this. Okay, I can decrease the resistance almost to 0. Or rather about 80 ohm lah. It's not going to be 0. If I remove it, it will go back up again. Pretty cool, right? Okay, so I like to pretend I'm telling ghost story, but actually maybe the entire physics is a ghost story. Too horror story. Physics itself is a horror story. All right, anyway, I think we're ready to start the experiment already. So this is going to connect to this one. We have played with it. We have understood how it works. I'm going to keep this here, so you can see. Give me a sec. All right, so once again, this is in kilo ohms. All right, and we're going to make sure that this one is lighted. Okay, so we're just playing with the instrument. Okay, so if I connect, okay, you see, if I take this one and stab it, I mean touch it, taking the horror theme too far, the light will turn on. So I'm just going to put it in here. Then what I'll do is, okay, observe the meter reading. I put it inside. So it's around 1 point something. I push it inside some more. Wow, you can see it's dropping because the light intensity and brightness is more. You are going closer to the light bulb. Okay, so we're going to probably have to do something like that. I don't know. Let's read the experiment. I'm going ahead of yourselves. All right, let's see what is next. Ding, ding, ding. Measure and record the distance L from the lamp to the open end of the tube. Okay, sure. I'm going to measure from the end to the open end of the tube. Let me go grab myself a handy dandy ruler. I am back with a ruler. So I think you'll be given a 30 cm rule or a half meter rule, but I think a 30 cm rule is good enough for this purpose. Okay, so I'm gonna put this like this. All right, I'll try to align this to 0. And now you can pause the video and see the recording. Pause the recording and take the reading. Okay, so on one side, this is 0. Let me adjust a bit. Actually, you need to look from here lah. So you don't want parallax error. Your view should be here. So 0 here. I'm going to go all the way to the back. So pause the video. Take the reading. Okay. Take the reading for L. Don't forget all the normal things lah. Decimal point, SF, units. So nice. Okay, so we already have L. We're going to continue. Measure and record the distance X from the front of the LDR. I'm just going to highlight this because I don't know why every year people ask me, where's the front of the LDR? To the end of the half. Okay, so there is no half meter rule. So it's the end of the PVC pipe. Okay. Okay, so where's my LDR? There we go. This is the LDR. I'm just going to put it this way. We're going to measure from here. This side here, this side, this side. As I grow older, I sound more and more like my mom. And all the way to here. end of the PVC pipe. So here, I guess. I mean, I'm going to measure to the red color stopper lah, okay? Because I think this one is just how to measure. It's not even cut evenly. You can see the... Okay, so I'm going to measure until the end of here. Okay. Again. Whoops. To the end. No, wait. As shown in figure 1.1. So if some of you is like yelling to the video, no, miss, you are wrong. You need to check the diagram, miss. Good job. Where is X? All the way to here, this end? No. It is this end. Hiyo. So sneaky one. Where got sneaky? They draw for you already. They even remind you to refer back to the diagram. So you don't just go happy. Okay? Alright, anyway. Enough. We're going to measure now. Oh, because this is going to be a bit hard. Let me see if I can hold this properly for you. With the ruler in view. So that you can measure this. Be hard, bros. Okay, so I'm going to try my best again. And I think I'll put the 0 at the top of the LDR. Wah, punya lah, susah. Okay, so I'm gonna judge it based on what I see on my screen, okay? Which should be what you see at home. So the top of the LDR is here, where my thumb is. So or not? This is the top of the LDR. Okay? To the PVC piping. So it is less than 1 cm hor, right? Where my thumb is to the end, the gray color or the white color tape lah, where the tape begins. That is your X. So I think I have more or less not have any parallax error already, but if you think there is, then you estimate yourself lah, okay? So once again, pause the video and take the reading for X. Okay, good enough now. Write your reading. We are going to continue. Oh, my. Alright, so now we're going to push this one with the ruler marking here into the tube. The one with the bright lights. Ting ting. Okay, so I'm going to put this in. And like I mentioned just now, I don't want to burn my light bulb, so I will only connect when the experiment starts. Okay, push the rule into the tube until the LDR is approximately halfway. Okay, so where is halfway, guys? Feels like a maths question, right? Although they say approximately. Okay, I'm going to put all this wire one side so it doesn't disturb our Zen. Wires are all here. It's all connected. This one is connected to this meter. I'm going to just put it aside, okay? But I'll keep the meter in view so we can still take readings. Cool? Alright, so let's see what to do. Okay, I need to make sure I don't knock off the laptop. Okay. Anyway, so now we're gonna put the LDR at roughly the halfway point. Okay, so what I do is I'll put everything inside. This is the full way point. Is there such a thing? All the way. All the way. Sorry, my brain is very messed up. Anyway, this one is already all the way inside, okay? You can see I put like this. Gravity has pushing it all the way inside, so I'm just going to tilt it this way. Alright, so you can now see this reading. It looks like... I mean... Sorry about the reflection. Okay, it looks... maybe a bit like 27.6. Right? 27.6, okay? So if you pull it all the way out, it can go to as low as 0 lah, obviously. Okay, so the halfway point between 27.6, which is about 28, is about 14. Okay, so I'm going to allow the value of P to be 14. Okay, so somewhere here. Now, I don't think my hand putting this is good for you when you take reading. So I'm going to pause the recording and zoom in to make sure that you can see the scale on the PVC pipe. BRP. Okay, I'm back and the different place so that I don't block the meter. Alright, so you can see now my the P is halfway. Okay, so we have to measure. Actually, we have to measure. You know what? If the length L just now is the whole thing, so we have to measure from the end of the PVC piping here. This is L, remember? So this was your 27.6, right? Okay, so we want P to be halfway along. So I could put 14, but 14 will still be measured from this 27.6. I'm so nice, right? I tell you. Alright, come. This one is fully in now. Cannot go in anymore. Too big now. So this one, too long, too big. This, on my scale, looks like 27.6 cm. Okay, so we can take 14 as a halfway mark, but please remember how to take the reading. If you just take 14, or remember how this one is 14. So 14 is here to here, because you pull this one out. Okay, we're going to measure the end of this one is 0. So when this one is fully in, this one is 0 cm. Okay, so this 27.6, if you want halfway, the 27.6 is somewhere here. So if you take this one as 14, just be aware of what lengths you are supposed to do. Okay, don't be a bit of like the confused person and then go and take 27.6 minus 14, all sort of weird things lah. Shouldn't happen, right? Anywho, if you hear fireworks, because I'm recording this during Chinese New Year, see my Chinese New Year baju. Miss, Chinese New Year still have to work, yeah lor. You also Chinese New Year still need to study. You got study or not? Study and break lah. Study a bit, work a bit. Okay, anyway, this is about 14. So the inside of the LDR, I have to trust lah. It's somewhere inside here you cannot see. So 0 is already marked out here on the tape, and this is 14. So you can write your P value. Please make sure you know the DPSF thing unit, you know lah, okay? Then calculate the distance D of the LDR from the lamp. So you want to find this distance, you will take L minus P minus X. L minus P minus, okay lah, you do what you need to do lah, okay? Because remember you have L and X. Here you have written your X, in this one you have written your L. Okay? So switch on the lamp. Okay, so we have calculated the distance D here to here. Okay, if you are unclear, just pause the video, brain the situation a bit, okay? Then switch on the lamp and take the resistance meter or multimeter reading. Okay, I'm going to bring this back in frame. Okay, and now we will turn on the light. I'm just going to keep this at 14 Can see more 14. Sorry lah, it's terbalik or flipped, but I guess that's the orientation of the tube. I could flip it backwards, but then it won't look like the diagram, and some people will get confused. So I think you just... I'm pretty sure you know how to look at 14 that is inverted lah, okay? You are okay. Alright, so now I'm going to turn on the light by plugging in the power supply. Time to make a cameo, okay? So I'll plug in the power supply, and this is the value of R at 14 cm. When P is 14, this is the value of R. Okay, take the reading, and then we are now going to move on. You could take 2, but the reason why it fluctuates is because of the connection. But yeah. So this is good enough lah for me. Take lah whatever reading you think is a stable one. Okay, doesn't really matter. Okay, moving on. Repeat C using different values of P until you have 6 set of P and R. Okay, sure. Let's think about it first. We need to plan a bit. We need values of P, and your P has to be less than 20 cm. Okay, so this P is 14. The P is 14, right? So when you bring P can go as close as 27.6, measure before now. So the biggest one I would take is 27 lah. But then P must be less than 20 ho. So the biggest one I can take is 20, not 27. So let me think. Let me brain a bit. I can take 20. Whoops, didn't change color. Pen. So I can take 20, 0.0. Okay, because this is a meter rule lah, okay. And then I can take, I guess, what's the smallest one? I wonder, what is the smallest possible value? Of course, you could say, Miss, we take 0 lah. My friend, you want to take 0 or? You see that this LED is already LED, but LDR, the light dependent resistor, is already exposed to the surrounding light. Of course, I could turn off my room light and my face light here, but so I'm going to start with 1 cm lah. Okay, maybe 2. Alright, I just need to make sure I cover like around 90% of the range. So I think 2 cm is okay. So 2.0. You could do 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. But that one looks like a lot, right? So I'm going to jump every 4. Up to you lah. But you're not doing the experiment, so you're relying on me. So 2.4, then I'll add another 4, which is... That mean cannot add 4. So maybe I'll take 8.0, and then I'll take 12.0 and 16.0. 1, 2, 3, 4, 5, 6. Beautiful. And then you might be thinking, Miss, can I take 14? You can you can leave, you can... Sure. Because we took 14 already, right? Okay lah, might as well. I give you extra data. You could do it in all 2 cm increment if you want to. No harm. You know what, might as well lah. So this is my X. No, this is not my X. This is my P in cm. Alright, it's my P in cm. Okay, we are ready. My friends, you are ready to take the reading because I ain't going to take it for you. Alright, so this is 2 cm. Beautiful reading there. Put it down. We want values of R in ohm. Okay. Okay lah, this is 2 cm. I'm gonna go for 4. Okay, this is 4 cm. Quite cool. What easy one, this experiment. Okay, 4 do liao. Okay, come, let's do 8. Okay, this is 8 cm. Okay, we do 8 already. So now it's time to do 12. Okay, this is 12 cm. Or at least my perspective of 12 cm lah. Okay, we're going to continue now to 14 because we had 14 just now. So we just want to double check and make sure it's around the same number. Okay, and now we're going to move on to do 16. 16, somewhere here. Okay, this is 16. And continue with 18. And finally with 20. Okay, so that's all the data you need. You have more than enough. Okay, of course, if you're doing this in person, you can take more. I am going to do the good thing by disconnecting this, and you see it will drop. So it will drop, it will go up to infinity because no light inside to give it energy. No energy. The electron don't want to move. Don't want to move. Large resistance. Okay, so you're plotting a graph of r on the y-axis and d to the power of 1.5. IDK, what on earth is happening here? Is it a typo? Use LaTeX. Don't use Microsoft Word equation. So d to the power of 1.5. You know how to press power 1.5, right? This would be d to the power of 3 over 2, which is d power 3 and then square root. Okay, so make sure you know how to calculate your d. The equation is here. Okay, so with your complete reading, you can complete your table. We need to have the values of d and d to the power 1.5. Same thing apply. Unit SF. Last experiment already. Please don't make same mistakes. Unit SF, DP, header, all that. Please make sure it's clean, it's perfect, it's beautiful. This is such a straightforward experiment. You got this. Okay? And then you draw the straight line of best fit, all that, blah blah. It's new, it's not new. Okay, graph. And then you're given the equation and you have to find A and B. Pretty good, all right, if I do say so myself. So go ahead, give the data a try. Hopefully, if this comes out in the exam, you will take the time to actually look at all the equipment given to you so that you don't panic. Don't be like, yeah, why I never see PVC pipe before one? Why I never see this one before one? Achievement unlock. It's a new level. Children, it's a new level. So that's it for this experiment. Make sure you do the right thing. Don't do the wrong thing. And whenever people give you new stuff like this, take some time to get to know it lah. They are not that hard to get to know. You got this, bro. My boys, I will see you, and girls, I will see you in question 2. Ciao, adios, amigos.